In this video, we're going to show that the matrix M is symmetric, which means that M equals M transpose. And M is one of the essential matrices when we're talking about linear projections. And proving this property involves using very simple properties of matrix transposition. And I think it can illustrate how to tackle some of the exercises that involve this. So let's just start by writing down what M is, which is given up here, which is just the identity matrix minus X times X transpose X to the minus 1 times X transpose. And since we want to show that M equals M transpose, let's take the transpose of M. Let's take the transpose of M, which is going to be equal to the transposition of all of this. And to proceed forward, all that we have to do is that we have to use the property of the transpose of the sum of matrices, which is basically the following, is A plus B transpose is equal to A transpose plus B transpose. So let's get right to it. Basically, we can distribute the transpose along the summation. So we're going to have that M transpose is equal to the identity transpose minus this big matrix transpose, which we're going to operate very soon. All of this transpose. So the first thing to note is that the identity transpose is just the identity matrix. And the reason is that, remember, the identity matrix is just a diagonal full of ones and then zeros everywhere else. So when you flip it by transposing it, you get the same thing. So M transpose is just going to be the identity matrix minus all of this, which to operate on this, we just have to use the properties of the transpose of the multiplication of matrices, which says the following. A times B transpose is just going to be equal to B transpose times A transpose, which basically means that, you know, what I say for the multiplication, for the transposition of a multiplication, is just flip the order and transpose everything. So the matrix that was first is going to be last, and the matrix that was last is going to be first, and you're going to transpose everything. So let's apply that to this matrix right here. So we're going to have to start with the X transpose. This is going to be the first term because it was the last originally, and we're going to have to transpose. But X transpose is just X, right? If you transpose twice, you get the same thing. Then we're going to have the term in the middle, which is still going to be in the middle, which is going to be X transpose X to the minus 1 transpose. But since this is a symmetric matrix, the transpose of this is just going to be the same matrix. So this term is not going to change. And then finally, we have the X that began the multiplication in the previous term. Now it's going to be the last term. So I'm going to have X, and I'm going to have to transpose it. So it's going to be X transpose. And notice how this M transpose is the exact same formula than M, right? It's just the identity matrix minus X times X transpose X to the minus 1 times X transpose, which is the matrix. This matrix is sometimes called P, which is the projection matrix. So we just proved what we needed to show, right? We showed that M equals M transpose, and it just involved using some very simple properties of the transposition of matrices.